So today we're going to focus on calculating the mass of a mole. So in this picture, I have multiple different substances. I have aluminum, I have copper, I have table salt or sodium chloride, I have sucrose, which is C12H22O11, so it's a much bigger molecule, and we have good old water. And all of these in this picture represent 1 mole of every single substance. So, if we look at copper and aluminum, a mole of copper takes up less space than a mole of aluminum because our copper particles are more dense, so they're more packed in than the aluminum. If you compare our two white substances, our sugar and our sodium chloride, a mole of table salt, which has 2 atoms, takes up less space than a mole of sugar, which has many more atoms there. So, we also have a mole of water, which is a liquid form, and I believe it's about 18 grams. And this takes up less space than a mole of sugar for the same reason. It has 3 atoms, whereas sugar has a lot. So, the mass of 1 mole of any substance is its molar mass, and it's represented by grams per mole. We can actually pull all these values from the periodic table. So here we have carbon and copper. And on the periodic table, there's always been that number we've went back and forth to. We looked at it when we were looking at isotopes, and this is the atomic weight. This also represents how many grams per 1 mole of that element. So there are 12.011 grams per 1 mole of carbon, and there are 63.546 grams per mole of 1 mole of copper. So, our molar mass is the mass of 1 mole of an element. It is the atomic weight multiplied by 1 gram per mole. That's why we're able to pull it right off the periodic table. And like I said, they change on different elements. And we can use these molar masses as our conversion factors. If we think back to 1 dozen apples is equal to 12 apples, it's the same idea. Our molar mass can be represented as a fraction and used as a conversion factor to convert a known mass into moles or known moles into mass. I do to the 100th. If you do it to 1 decimal place, that's okay. Alright, in this video, I am going to actually record it the right direction, so I hope it's easier to watch. And we're going back to our balloon problem. We still have our 5.75 moles of helium, but we want to find the mass. And we're going to use this fact that I pulled from the periodic table, where 1 mole of helium is equivalent to 4 grams of helium. I just had to pull it from the periodic table because the masses that are listed there are the masses per mole. So I have 5.75 moles of helium, and I need to cancel out my moles to get to grams helium. We have our fact above, 1 mole helium is equal to 4 grams helium. And I can just do simple math, where it is 5.75 times 4, and that is equal to 23 grams of helium. Now, we can pull the molar masses of elements off the periodic table, but what happens if we have compounds? Here we have sulfuric acid. It is made up of 2 hydrogens plus 1 sulfur plus 4 oxygen, and it looks like this in the ball and stick model. If you look at the periodic table, their atomic weights are 1.008, 32.06, and 15.99. What we can do is we can multiply each of these grams per mole, their molar mass, by the amount of atoms that are present in the molecule. And that's what's done below. So for 2 moles of hydrogen, their molar mass is 1 gram hydrogen, and then you have 1 mole in the denominator to make sure units change. Plus, there's only 1 mole or 1 atom of sulfur. So for 1 mole of sulfur, it is 32.1 grams sulfur. And there are 4 atoms of oxygen. So you take 4 times the 16 grams oxygen. And you'll find that the molar mass of the entire compound of sulfuric acid is 98.5 0.1 grams per mole, and we can use that conversion factor in our calculations just like we would for an element. Alright, so in our next problem, we are going to calculate the amount of moles in a compound instead of just one element. So, there is 30 grams of sodium chloride in a beaker. How many moles are in the beaker? Well, the first thing we have to do is figure out what is the mass of sodium chloride. So 1 mole of sodium chloride is the same as 1 mole of sodium plus 1 mole of chlorine. And since they are just 1, we don't have to worry about multiplying or anything. I'm going to use my facts from the periodic table that 1 mole of sodium is equal to 22.9 grams sodium, and 1 mole of chlorine is equal to 35.5 grams of chlorine. That's just simple addition, so 22.9 plus 35.5, and you plug that into your calculator, and you get, oops, that zoomed in way more, 58.4 grams sodium chloride. Now we have the thing we need to help us for our problem. We can actually solve the problem. Our given is the 30 grams sodium and chloride, and we want to go from grams to moles. So since we have grams in the numerator, we need grams in the denominator. So there are 22, oops, that's the sodium value, maybe. There are 58.4 grams sodium chloride per 1 mole sodium chloride. If you're going to plug this into your calculator, it would be 30 divided by 58.4, and that is equal to 0.51 moles sodium chloride. And we can go back and check if we did our dimensional analysis right by looking at what cancels out. I have 30 grams in the numerator, 30 grams in the denominator, so that is the same as 1, and I'm left with moles sodium chloride.